Right. This is chapter 4H. Today we are going to be covering volume and capacity. So it's pretty much the next step to prisms and all that, which I taught you previously. Okay. So the goal here for today, so a couple things you need to know. Volume is the space occupied by 3D object. Okay. So just think of area as the space occupying a 2D shape. Volume is for 3D shapes only. Okay. Yes. Capacity is technically the volume, but it's mainly for fluid or gases that are usually held in a container. Okay. You should be able to convert between units for volume and capacity. So there are some special conversions which I will cover. And you are going to find the volume of rectangular prisms and all that. All right. So these are the main units of measurements you need to know for volume, okay? And they're measured in cubic units. So you got cubic millimeters, cubic centimeters, cubic meters, and cubic kilometers. Here are how they are written out. Now, copy down this flowchart here. So you're going to need to know this flowchart on top of your area flowchart and your regular flowchart as well. So I would recommend writing this down in like your little cheat sheets once the test approaches. And at the bottom here, we have a little example as to how you would actually convert in the flowchart. So in my example here, I have 3 meters cubed and I need to convert that into centimeters cubed. So just basing it off the flowchart, I need to multiply 3 by 100 cube. And that just ends up with 3 million centimeters cubed, okay? All right, capacity. So you know that capacity is just the volume of liquid or gas in a container, but capacity has like their own special units of measurements. So you have milliliters, liters, kiloliters, and megaliters. This is the flow chart here. Copy this one down as well. Now these are the special ones, okay? These are the special conversions that you will need to know. So the first one here, probably one of the most important ones. So to convert between capacity and just regular volume, just know that 1 centimeter cube is the equivalent of 1 milliliter. Now you should know that uh, 1000 milliliters is the equivalent of 1 liter instead, and that is based off this flowchart here. So if I have 1 milliliter, so if I have 1 liter and I want to convert that to milliliters, I just multiply by 1000, okay? So just use this flowchart as a good basis here. And 1 kiloliter is the same as 1000 liters, and 1000 liters is the equivalent of 1 meter cube. So this is the second most important one, okay? So you should know how to do all of this. All right. So this is the formula for volume of a rectangular prism, okay? So you have length times width times height here. So this is what the rectangular prism will look like. Just make sure you label out your measurements first so you know what you plan on substituting in. And this formula here is for the volume of a cube. So just look at the dashes here. These mean that these are of the same length. So that means that's L. And the height here is also L. So length times length is the same thing as L cubed, okay? Now this is an extra one here. So volume of a triangular prism. Not sure if this will be covered specifically, but I might as well just show you it now. So I think this is it. Yeah, so the volume of a triangular prism is half times base times height times length in this scenario. Now, one thing you should sort of start eyeing is this section here where it says half times base times height. That's the same thing as the area of a triangle. And the only thing you are doing on top of that is multiplying by like a height or such, or like the length slash height, depending on which shape you're dealing with. Okay. So as you can see here in my diagram, in red, which is the front, that's just the typical area of a triangle. And all I'm doing at the end is just multiplying it by this L length here. And that's why, like, it's a bit weird, but like, it's pretty cool at the same time, you know? Now, another way to write this formula here is this section here, base times height times length, and then you just divide it by 2 afterwards, okay? So in this example here, we'll just walk you through it. So we need to find the volume of this particular shape. So this shape is a rectangular prism. So I would always start out by writing the formula. So V is equal to what again? Length times width times height. Right? And then you can just start labeling things. So my length, I'm just going to say my length is 6 meters, my width is 4 meters, and my height is 2 meters. Okay. So with that being said, I can just substitute these numbers into the variables. So this will now become 6 times 4 times 2, and that turns out to be 48 meters cubed. Now, just remember volume, so you have to use cube now, okay? Um, we'll just walk through this, but yeah, you should be able to do this yourselves. But just remember, just start out by writing the formula. Length times width times height. I know my length is going to be 5 meters. My width is going to be 4 meters, and my height is going to be 3 meters. Substitute the numbers in. 5 times 4 times 3, which equals to, no, 60. 60 meters cubed is 5 times 4 is 20, and then you just do 20 times 3, which is 60. Or you can just use your calculator. It's perfectly fine, okay? And find the capacity in liters of a container that is a rectangular prism 20 centimeters long, 10 centimeters wide, and 15 centimeters high. Now, I've put in the flow chart here, and I've put in like these special conversions just so that we can actually see what we plan on doing. So let's just start off by finding the volume of the rectangular prism first. So we know length is 20 centimeters, width is 10, and height is 15. So if we just plug it into our formula now, this will give me 20 times 10 times 15. I believe this ends up being at 3,000 centimeters cubed. Now, because the question's asking to find the capacity in liters, I need to start making conversions now. So why don't we just convert 3,000 centimeters cubed into liters? So just looking at the flowchart here, 1 centimeter cube is the equivalent to 1 milliliter. So that means this 3,000 centimeters cube actually now turns into 3,000 milliliters. But the question's asking for liters. So to convert 3,000 milliliters into liters, I must now divide by 1,000. Okay? So that's just based off the flowchart here. So if I do that, I end up with 3 liters. Okay? And that's pretty much the final answer. So it's not as complicated as you may think. All right. This is activity question. I'll just go do it as well. Find the capacity in liters of a container that is a rectangular prism 25 centimeters long, 10 centimeters wide, 10 centimeters high. Okay. So let's just start out by finding the volume. So that will be 25 times 10 times 10. This will end up being 2,500 centimeters cubed. Now just follow the same conversion again. I am now going to convert 2,500 milliliters into liters. Oh, this 2,500 centimeters cubed to milliliters. So 2,500 centimeters cubed is equal to 2,500 milliliters. And then you just convert this to liters, okay? Which ends up being 2.5 liters. And that's it. So these are the questions you got to do. Make sure you do the base, which is up here. And if you're feeling zesty, then go through the challenge questions, okay? Take care. Bye bye.